Hi, I'm Jack Heslin, founder of the AI Conversation, an online community where individuals and organizations from diverse backgrounds come together to learn about and how to share AI tools. The goal is to develop a best practices AI forum so that none of us have to figure out how do we use this AI technology so it does the most good for all of us. Well, we've come a long way. And today we're at Module 7 of our AI 101 series. We've climbed to the top of the pyramid. It's been quite the climb, no question. And today at the very top, we're going to explore AI robotics. This is an extraordinary technology that brings the artificial intelligence we've been talking about, which, if you stop and think about it, has all been virtual, into the physical world by embedding it into robots. So, as you know, we've been using animal metaphors to explain each AI technology in our pyramid. Well, for AI robotics, we've chosen ants. Yes, ants as our metaphor because these tiny, remarkable creatures are masters at sensing their environment, making decisions, and then taking coordinated physical action, which is exactly what AI robotic systems do. So just like ants can and do work together to build complex structures, carry objects many times their size, robotic systems combine their AI brains, those virtual things we've been talking about for the last several modules, with their mechanical, we'll use the word bodies, to accomplish impressive physical tasks. So now that we're at the peak of our AI pyramid, we'll see how AI robotics represent a culmination. It represents every layer building on every other layer to get to this top technology of everything we've explored so far. So let's talk about this a little more in depth. Why ants? Um, if you think about it, it's a perfect match. Ants use their antenna to constantly sense their surroundings, just as robots use various sensors to gather their environmental data about the world around them. When it comes to decision making, ants follow something called a pheromone trail, and that responds to which they respond to specific signals. This is similar, actually is quite similar to how robots use algorithms to process information and determine their next moves. Most impressively, ants work together. They work together in a coordinated action to accomplish physical tasks like building colonies or gathering food, mirroring how robotic systems perform physical work in our world. So, this three-part process, sensing, deciding, and acting, is it's not only at the core of how ant colonies function, it's at the core of how AI robotic systems function. So let's get back to our pyramid here. We've seen this pyramid now in every module going back to machine learning. We've reached the top. AI robotics represents the pinnacle that brings together all the layers we've explored on our journey. This technology, but it doesn't exist in isolation, and that should be very clear now. It's built on the foundation of machine learning that enables robots to adapt their behaviors based on experience. Remember, we said that in that ML module. This machine learning learns from experience. So that was the metaphor for that was the Clydesdale. Then the neural networks provide the pattern recognition capabilities that we explored with the octopus, while expert systems create rule-based decision making, kind of like a beaver, following specific rules to make a dam. Natural language processing allows for that human-robot interaction, just like how we interact with parrots. And then finally, we got to computer vision in our most recent module, where the metaphor was that soaring eagle with the remarkable eyesight, very much like the eyesight of computer vision. So all that comes together to bring us to the top of the pyramid, AI robotics. This is where all these technologies culminate to create a system that interacts and really can manipulate objects in our physical world. Now, you may have noticed that in all these technologies that we discuss, there are always components that make them up. the key ingredients, if you will. So every robotic system, whether it's factory arms building cars, right, even to a household vacuum robot, they all have the same four essential components that work together. First is sensing. This allows the robot to gather information about their environment through various sensors. These are like the robot's eyes, ears, and increasingly so, sense of touch. Next comes processing. Process that data that it's taken in. This is where the robot's brains make decisions based on sensor data and programmed objectives, determining what actions to take. Actuation, this is an actual next component, is where we'll use the metaphor, rubber meets the road. The physical movement of this AI robot through the world with a combination of motors and mechanical systems. This is what allows the AI robot to manipulate physical objects and move about in our physical world environment. And then finally, we have what we call the integration, the last of the components. This ties everything together into a cohesive system that ensures all the components work in harmony, much like how an ant colony functions as a unified entity despite being made up of individuals. That's a big, big deal. Now, something else you probably noticed in all of our modules is that not one of these technologies is singular. There's always types of them. There were types of machine learning, there were types of natural language processing, and so on. So keeping with that, no surprise, there are types of AI robotics. So it's actually a very diverse world. Service robots are becoming increasingly common in healthcare, helping with everything from delivering supplies in hospitals to actually assisting surgeons in operating rooms. Now, that's still very much in testing. A year from now, we might say it's becoming more and more common. But this is actually happening. AI robots assisting surgeons in an operating room. Still very much, in beta, as they say. My own opinion is this will become quite common. I don't know if it'll be 5 years or 10 years, but this will become more and more of a norm, in my opinion. Autonomous vehicles, that's the one people are most familiar with. This includes self-driving cars, delivery drones that use AI to navigate safely through complex environments. Industrial robots, revolutionized is a word that gets thrown around quite a bit, but it's accurate to say industrial robots have revolutionized manufacturing with their precision, the eyesight, precision tasks, ability to manipulate objects, and consistency in assembling products that include everything from cars to smartphones and everything else in between. Maybe the most extraordinary frontier that's coming are what we call collaborative robots or cobots. These are designed to work alongside people, you and me, which will enable a whole new level of combining human creativity with robotic precision and strength to achieve better results than either the robot could do alone or we could do alone. Now, you may have also noticed in our pattern that we always talk about the advantages of an AI technology or the challenges. I don't want to use the word disadvantages, but the challenges yet to be had with it. So, just like our other modules, we'll start with what are the advantages of AI robotics? Well, some of them are really game changing, starting with the physical capabilities that go far beyond human limits. Whether it's lifting heavy objects or working in extreme environments, the consistency of robots means they can perform precise tasks repeatedly without getting tired, without getting bored, or at making errors due to fatigue. Risk reduction is another huge benefit. Robots can take on dangerous tasks in places like disaster zones, deep mines, handling hazardous materials, and the scalability of robotic systems allows them to work continuously in coordination with other systems. And perhaps most important, the best robotic applications focus on augmentation, not replacing human beings, but giving human beings capabilities not to take our jobs, but to help us do our jobs better. Now, as we've already talked about, and as we always talk about in these modules, every one of these AI technologies has its advantages, but there are always limitations. There are always challenges. These will very likely decrease over time. But today, for AI robotics, despite all the impressive things that they can do, they do face real challenges in dealing with our human, messy, chaotic, unpredictable world. we're the messy ones. The robots, with their logical algorithms, they don't deal well with mess and unpredictability. So, between that and the physical constraint, present major hurdles. Robots struggle with things like uneven terrain, unexpected obstacles, changing environmental conditions that we adjust to without even thinking about it. And then, of course, you have something called the dexterity gap that remains quite the challenge to be addressed. Even with the most advanced robots, they find it difficult to match the fine motor skills of human hands. I've never seen a robot sew. I'm not saying there isn't one, but that would take a very fine to, put the thread through the needle, do the, could a robot do that? Maybe someday, but not yet. Something else we do very easily is pick up a glass of water. I'm not squeezing too hard, so it would crush the glass if I was a robot. I'm not holding it so soft that it would fall off out of my hand. We don't think about those things. Those are still challenges for robots. So these limitations remind us that while the robots are extraordinary in structured, predictable environments, you can throw them a curveball in the real world pretty easily. It's actually a reminder of just how extraordinary we are as people and our adaptability. And the limitations go on. Energy, energy requirements. This is a significant challenge for robots. And just a reminder, something I've brought up a few times in this AI 101 series is that the power consumption of artificial intelligence in general is quite high. You can make a good argument. This is not a green technology. Now, with robots, the challenge, particularly for mobile systems, not mobile devices, but mobile robots to go through like a warehouse, it can't stay plugged in, so it needs a battery. Well, battery technology still has limits. So how long can the robot run on its own? How can it work to the highest level of its capacity? Does that drain the battery quicker? These are still things that have to be addressed. And then, of course, there are safety concerns which are always paramount to ensure that the robots can detect people, avoid collisions, or any kind of harmful interaction. That always has to be paramount. And then, of course, finally, as we get to with all AI technologies, the ethical and social implications of increasing automation that raise important questions about job displacement, about privacy, how we want to shape our shared future with intelligent machines. As robotic technology advances, we're going to have to address these limitations. And quite frankly, we're probably going to come down to some philosophical debates. What is the right way to roll this technology out in society? Having said all that, this genie's out of the bottle. The future of AI robotics is really quite exciting. Yes, there are challenges and limitations, but the horizon is endless. There are several key trends, kind of like the ant colony, that are really, really extraordinary. We're going to see increased autonomy in the AI robotics. It'll give them more ability to make independent decisions in complex environments, similar to how ant scouts can solve problems on their own. Improved human-robot interaction will make working with robots more intuitive, more natural, much like how different ant species have evolved to communicate effectively. Soft robotics, a term we haven't talked about at all, represents a revolutionary approach with flexible, adaptable, physical forms inspired by biological systems. So imagine robots that can squeeze through tight spaces or gently handle delicate objects like we just talked about. And perhaps the most ant-like of all is the idea of this distributed intelligence, where swarms of simpler robots can work together to tackle problems that humans, either individually or collectively, simply can't do. That's the view from the top of our pyramid with AI robotics. So that brings us to the end. We started at our bottom layer of machine learning. We have gone up layer by layer until we've gotten to the top of our AI pyramid. Something very important to remember is this pyramid should be seen as a snapshot of today. This is an evolving technology. We could do this presentation, the series again, a year from now, and it would be different. Maybe there'll be new applications. Well, there'll certainly be new applications to include, but there might even be another layer we want to put in, or maybe put a layer on top of AI robotics. We don't really know what's coming, but this is an extraordinary time. This is probably going to prove to be every bit as transformative a technology. This is my opinion, but many people feel this way, as the printing press was 5 centuries ago. And that's why I started the AI conversation, a place where people from all backgrounds, non-technical, not for people who just write the code, but people from all kinds of backgrounds come together and share their opinions about how to use AI technologies, what works, what doesn't work. And in that way, we all learn together. So, my name is Jack Heslin. I'm the founder of the AI Conversation. Check us out at www.theaiconversation.com. Thank you very much for joining us these last few modules. We hope you've learned something. We hope you've enjoyed climbing the AI pyramid. And come join the AI Conversation. We'd love to know what you think. Bye.